The ice wedges of the Arctic coastal plain of Alaska are responding to global warming in complex ways. We mapped ice wedge degradation at this site along the Dalton Highway in Alaska to examine that complexity and hopefully identify the underlying drivers of thaw. We can clearly see in satellite imagery here that some parts of this landscape are severely thawing, while other areas, which are sometimes right next door, are not. Our goal with this project was to map and examine this heterogeneity. We first identified ice wedge networks using a machine learning image classifier, then assessed the severity of ice wedge degradation by examining the spatial and spectral signature in those ice wedge troughs. I have two main takeaways from this work to share with you. First, when we examined ice wedge degradation at the meter scale, we found that ice wedges in the advanced stage of degradation tend to occur lower on the local landscape, where we would expect to see positive warming feedbacks from water pooling and thermal erosion. Second, when we take a step back to look broadly across the landscape, we can clearly see there are these hot spots of degradation. At this broader kilometer scale, the relationship between degradation and elevation is flipped. We see hotspots of degradation occurring on the higher points of the landscape. These hotspots of degradation might be related to the geomorphic history of this landscape, which would control ice wedge age and therefore size, or soil thermal dynamics, which impact the amount of insulation available above the ice wedges. Older, larger, and less insulated ice wedges in higher elevation areas would therefore produce these hotspots of degradation. Thank you.